this is about image analysis using Galaxy. This is my name. So I'm Beatriz Serrano-Solano. I work at the Euro-BioImaging BioHub at EMBL in Heidelberg. And then we have also two other speakers that are Leonid from the Biomedical Computer Vision Group in Heidelberg University. And we have another demo from Ricardo that is from the Helmholtz Center for Environmental Research. So we three will cover the different talks. So after the demos, I will come back with some take-home messages. But for now, we'll just introduce what Galaxy is. If you never heard of it, it's a platform for data analysis that's open. You don't need to store anything. It's all web-based, so you only need the browser to use it. And the aim is to have accessible, reproducible, and transparent computational research. There is a Galaxy Hub in which you can find all the information about the project, and this is in galaxyproject.org. So the different servers, there are many different servers out there, and this is all collected in this galaxyproject.org, the Galaxy Hub and the use section. And we have plenty of Galaxy servers out there. Some of them are open, some of them are inside organizations, institutes, local to countries, to regions, to particular communities. There are some also that are totally open for everybody to use, and there are three very big ones with big compute infrastructure behind. And that's the European Galaxy server, the one that we're going to be using today. And that's accessible through usegalaxy.eu, and that's where we also have our tools and so on. And we have also another one, usegalaxy.org in the US, and another one in Australia, which is .org.au. So the tools that we are developing for imaging in general are in the European one, but it's a matter of requesting tools to be installed there by the admins of the different other instances. We will also see today some of the demos will be on local servers, because sometimes this is making things faster for at least showing a short demo here. So this is how it looks like in particular for our community. So we develop a flavor for imaging that it's only gathering the tools that are relevant for us. And this is because in Galaxy there are like 10,000 tools, and this is too much to search, to navigate, and to find what you need. So we try to gather all those that are to imaging, machine learning, statistics, all these different fields that can be more related to us. That doesn't mean that the tools are not there. They are still there. It's just easier to find. And yeah, and so we have this front end, let's say, but the compute capabilities and everything that is on the backend is the same as for everybody else in the public server. So this is under the European one, and it's accessible at imaging.usegalaxy.eu. And I am going to show a bit how the interface looks like. You see on the left side that there's a button that is called Tools, and this is the one that is pressed at the moment. That means that on the left panel you find the different tools by categories. So each one of these titles that you see in there have plenty of tools inside. Then there is a central panel in which one can see the different operations that are going on. If you need to input parameters to a tool, all these different activities will be changing and appear in the central panel. So this is a very changing part of the interface. And on the right side, you will have a history in which you can record every step that you are doing. So basically, when you use a tool and then you use another tool afterwards, it's kind of recording in a format similar to what you would do in a lab notebook. So every operation gets recorded there. If you don't like the web-based aspect of this, there is also a possibility to access this programmatically through an API that is available as well. There are plenty of tools already in imaging related here, and we classify them in three different categories: on data management to access very popular repositories. You will see later as an example of this as well. On data processing, data analysis, many familiar tools here for you probably as well. And then we also have on visualization. And the very interesting part about this is that you can combine these different tool suites in hybrid workflows. So if you like doing, for example, the segmentation using cell profiler, but you like to analyze later on with something else, you can put this all together on the same workflow. And that's very nice for reproducibility and also for sharing with others. So today we will see that Leonid will cover the automation of workflows here using bioformats, SciPy and Scikit image as well. And then Ricardo will cover more the data management part with the Homero and the bizarre visualizations. There are many different tasks that can be done by each one of the tools, so that depends a bit on them, but we try to collect everything that you can now do with Galaxy, and that's getting the data, accessing the public repositories, accessing also your private Homero instance if you have one in your institute, also having a conversion of formats, uploading data back, and that's what Ricardo will cover later. Then we have plenty of operations that you can do on processing analysis. On AI, we also have the bioimage IO that it's now been developed, a tutorial about this on how to run these models on bioimage IO. And then we have plenty of data visualization as well, because remember, you don't install anything. There is no particular software, it's just a browser. So sometimes it's tricky to show things there, but we can show now TIFFs and SARs and so on. I will go very quickly through this because Leonid will cover that, but I will show now how one particular tool can be used in Galaxy. So let's say you want to use cell pose. Just type cell pose in the top search bar, and then something like this will appear. So you know this is the tool that you want to use and what you want to do with this one. And in the central panel, that changed, and now there is an interface of this particular tool. So you have all the different parameters that you can input there. And when you finish putting everything that is relevant for you, then you go to the run tool and execute it. And that triggers a cascading of events that are submitting a job to a cluster or to the cloud or to some infrastructure that in principle you don't need to know. All you need to do is to press this button, and then something will happen there and it will go and run somewhere else that maybe we don't even know if it's in the same local server or it goes somewhere else. So that's totally transparent to the user. And then when you have a more complex task that is not just one single tool what you want to run, then you can assemble a workflow like this. And here, each one of the boxes that you have with the blue header, these are tools, and then you plug them together to assemble a workflow. This is very simple. This one, it's very linear, so there's nothing complicated here. But it shows also when you display the workflow that you assemble, it shows also some metadata that is interesting to look at. For example, when you did that, in this case, it says that it was imported from uploaded file. That means that someone shared that workflow with me, and then I uploaded manually, and that was in 2021, and I put some tags there to identify the workflows, and you can also write a description about what this is about and so on. And then you have a section for workflows in which you can see everything that is yours. So my workflows are there, but then you can also have some that were shared with you within the platform. So inside that, you can share with a particular user, and that you will see here. And then public, if let's say, for example, that you have a publication and you want to have your workflow attached to it and you're going to make it public to everybody, that's an option as well. So you can publish it there. Interesting new feature. I think it's a bit old already, but it wasn't there when I was starting with Galaxy. So in that sense, it's quite new. So you have here also the workflow structure that I showed before, but now you can see that the headers are green instead of blue. And that means that this is an invocation. So that means a run of the workflow. So it was run. It's green, means that everything went well. But when things don't go well, you will see them red. So some of the boxes will go red. So you will go to this one and check, see what's happening there and what failed, and maybe there was a parameter that was wrong or something happened in the cluster, whatever. You will see this report there. And you see also at the top that it says 13 of 13 steps successfully scheduled. That means that everything went well, but if not, it will stop at some point and will notify you that something, you need to look at something. There are many things on the workflow invocations as well. So there was the overview what I just showed, but there is also a possibility to export. So you can also export as a research object, for example, in an arrow crate, so biocompute object, or can be simply a zip file. So this is also interesting if you want to share as a full object with all the metadata that you need to run it again. And also finally, the metrics are giving you some information about the runtime, about the memory that it's using. And that's also interesting to observe because sometimes we lose this perspective of how much resources we are using when we are running these things, right? And this is actually also being consuming resources that are harmful for the planet in general. So that's also something to pay attention to. You can also measure the performance of the different tools and see that maybe there is one that is more efficient than another and these kind of things. Finally, we have also interactive tools. So you can have here something like virtual desktops, for example, but you can also have Jupyter Notebook or R notebooks or these kind of things. There are also some tools that are purely interactive that can be integrated in that particular section of Galaxy, and it's called, you can access this through live.usegalaxy.edu. And this can also be connected to your automated workflow. So see, if for example, you have the whole pipeline that it's automated, but at the end of it, you want to have some custom analysis on it, then you can access the outcomes of your workflow, let's say some set of features that you measure in your image, and then go through Jupyter and analyze this in the way you like. Okay, final words about training that I want to say. There is a Galaxy Training Network. This is a very interesting resource that you can access with the URL at the bottom. And we have tutorials there, and there are more that are coming. So I mentioned before, there will be soon one on how to use AI models from the bioimage models too. But there are many different things from data management, from the different analysis using different tools. Today, there will be two of them covered that are here highlighted in bold. So Leonid will cover the introduction to image analysis, and then Ricardo will cover the Homero part. These are tutorials that are guided step by step with all the parameters that you need to put in the different tools, and everything that you need to do really step by step. So it's very easy to follow, and you can learn a lot with these things. There are also slides sometimes when you see here the symbol. I don't know if you see my mouse, I hope you do. But this kind of thing with the slides indicates that there are some explanation for introduction of the tutorial. Then there is a step-by-step guide, and then you have input data sets as well, and the workflows. Okay, finally, a note for the people that are doing training, actually. Like in the case that we do today, just don't have time to do the hands-on, but if we want it, we will have a special queue because we are using a public server, and that means there will be plenty of people using it. So that means that we may need to wait. And in our training, this is not the ideal scenario. You would want people to go all at the same pace and get their job scheduled very fast and then use their resources straight away. So in that case, there is an option that's called TIAS, in which we could request this special link. People will go into this particular queue. There will be some compute reserved for this training, and then for the trainer, it's also nice because you can track the progress of people. If they are stuck, if they had a red tool because something failed, and you can get feedback without the need to ask them.